Okay, so now we're going to get into how we're going to determine amounts in chemistry. And we are going to determine amounts with masses, but we're also going to count numbers, right? And it's not convenient to count numbers of atoms because there are so many. So just as the cook measures eggs in dozens, and the office manager measures pencils in grosses, or reams of paper, sheets of paper as a ream, right? Just as these people measure things with big numbers, with a term like that, right? 500 sheets is one ream, or 12 eggs is one dozen. Then we are going to do the same thing as chemists. We're going to measure a large number of particles in a unit called moles, right? So you may have seen this before. Now, 1 mole is equal to 6.022 times 10 to the 23rd. Here we're only given 3 sig figs, okay? 6.02 times 10 to the 23rd items, and that is Avogadro's number. And it's 602, 1,000, right? So I guess there's a million, there's a billion, here's another billion. So it looks like it's a billion, 602,000 times a billion, right? Big number, really big number. Okay? And so that will give us now amounts that we can actually measure in terms of sort of where we live, right? Like a teaspoon has got moles, certain number of moles of atoms in it, right? So our core chemistry skill for this section is going to be converting particles to moles of particles, okay? So 1 mole of an element is 6.022 times 10 to the 23rd atoms of that element. 1 mole of carbon is 6.022 times 10 to the 23rd atoms of carbon. 1 mole of sodium is this many atoms of sodium. Okay? And so we're going to be doing some conversions. So this is sort of just what you might imagine. 1 mole of just sort of a repeat of what we said in a previous slide. 1 mole of aluminum is that many atoms of aluminum. 1 mole of water is that many molecules of water, right? 1 mole of vitamin C is that many molecules of vitamin C, right? And 1 mole of sodium chloride is that many formula units. These aren't really molecules, right? That many formula units. No big deal. So let's do some conversions. An Avogadro's number, 6.02 times 10 to the 23rd, it can be written as an equality. We've done this before, right? 1 mole is equal to that many particles. And so we can have 2 conversion factors that we can derive from this. We did this in a previous lecture, right? Those are 2 decent conversion factors. So if I'm converting particles to moles, right? Particles will cross off and I'll be left with moles here. Or I can do the opposite there, right? So let's do an example. Avogadro's number is used to convert moles of substance to particles. How many carbon dioxide molecules are in a half a mole of carbon dioxide? So what I'm going to do is I'm going to come here and I'm going to say, well, the question is how many molecules, right? Molecules. And so I'm going to have a conversion factor over here that has molecules on top. And I was given moles. So I can go, oh yeah, I know how many molecules are in a mole, right? So I was given 0.5 moles of carbon dioxide, and I know that there are 6.022 times 10 to the 23rd. You know what? That's not fair, right? This textbook is only using 3 sig figs, so I'm going to say 6.02 times 10 to the 23rd molecules per 1 mole. Moles cross off, and I'm left with molecules. This is just like the conversions we were doing earlier. So hopefully that looks familiar. It's scary, right? Because we're using now moles, and it's really common for students to not like that concept in the beginning because it's so weird, right? All right, converting moles to molecules. There's an example of that. Let's do a learning check. Let's do 2 learning checks. Okay, pause the video and convert the number of aluminum atoms. Just a second here. Convert the number of aluminum atoms in 2 moles and see what you get. Okay, so I'm going to suppose that you paused it And so I was asked to find the number of atoms, right? And so I'm going to come over here. Oh, sorry, my whiteboard is a little bit, there we go. Man, terrible. All right, let me come over here and try to get a straight line. Not so good. Atoms, and I know that I can convert atoms to moles, and I was given moles in the first place, right? So I'm good. It looks like I was given 2 moles. That's 2.0. And I know that there's 6.022 times 10 to the 23rd. I keep using that extra sig fig, don't I? This textbook's only giving us 3 sig fig, 6.02 times 10 to the 23rd atoms per mole. Moles cross off, and I'm left with atoms. This is perfect. And 2 times 6 is about 12, and so it's going to be C. Right? Put that in your calculator. 2 times 6.02 times 10 to the 23rd, and agree with me, you're going to get that number right there. All right, so let's do another learning check, and then we'll be done with this lecture. The number of sulfur moles with that many atoms. What's the number of moles if you have that many atoms? Pause the video and come back and check your answer against mine. Okay, so again, I'm going to, the question is how many moles? So I'm going to put moles over here. Right? Let's do the picket fence method. We get a straight line. Moles, right? And I was given atoms, so we're going to say moles per atom. Right? I was given 1.8 times 10 to the 24 moles. And there are 6.022, man, 6.02 times 10 to the 23rd moles per, there's 1 mole for that many atoms, right? And 1.8 divided by 6 is like, this is the same thing as 18 times, this is the same thing as 18 times 10 to the 23rd, right? And 18 divided by 6 is 3, and I can see it right there, right? There's my 23rds will cross off. And 18 divided by 6 is 3, so it looks like the answer is B. All right, hope that's helpful. As I say frequently, we will get more practice in our homework.